BYD claim then of a 5-minute charge for the industry?
BYD have announced that their newest EV platform is going to be capable of charging at up to 1 megawatt of power.
Wang Chuanfu's recent unveiling of BYD's latest drive unit at the company's Shenzhen showcase felt to many observers like a declaration of war on the electric vehicle status quo. There, amid the hum of anticipation, BYD lifted the curtain on what it terms its new high RPM, high power density motor, a compact electric propulsion module capable of spinning at more than 30,000 revolutions per minute and delivering a peak output of 580 kW. Figures that, on paper, eclipse every mass-produced EV drive unit currently on the market. In a single stroke, BYD has staked a claim not merely for technical leadership, but some would say for market annihilation. If rivals cannot match these raw figures, they risk obsolescence. Before we start, please don't forget to like and subscribe to our channel for more updates. The dramatic implications of this motor's combination of power and torque density extend far beyond headline-grabbing statistics. In the short term, BYD's own vehicle programs, from its Han-L sedan to its forthcoming flagship SUV, will benefit immediately from performance curves and energy use profiles that challenge existing norms. But the real shakeup lies in the supply chain. A motor that pushes 16.4 kilowatts per kilogram by pairing advanced magnetic materials with an optimized thermal management package forces steel-stamped and aluminum-cast rotor designs into a defensive posture. Suppliers who once jockeyed on marginal cost advantages now enter a terrain where material science and precision manufacturing dictate survival. The knock-on effect is a potential consolidation of motor manufacturer partnerships, as automakers scramble to secure contracts with the handful of firms capable of meeting BYD's design tolerances, and by extension, to deliver performance parity. But BYD's weaponization of motor technology is only one leg of a three-pronged strategy. Simultaneously, the company detailed its so-called Super E platform, which fuses this motor architecture with a 1000-volt electrical system, government-caliber silicon carbide inverters, and an onboard charger rated for megawatt-class input. BYD's own figures promise 400 kilometers of range in just 5 minutes of charging, a claim that, if delivered in real-world conditions, would render existing DC fast charge networks virtually obsolete. Incumbents such as Tesla's supercharger network, peaking at 500 kilowatts today, suddenly appear underpowered and outdated. And when every minute of charging time translates directly into consumer convenience and dealer lot turn rates, the financial calculus of installing megawatt-capable stations becomes an existential concern for charging network operators. Implicit in BYD's announcement is also a strategic leveraging of vertical integration. Since its early days as a battery maker, the company has extended its supply chain control across cells, modules, pack integration, software, and now motors and power electronics. By internalizing each link, BYD can compress development cycles and amortize R&D costs far more aggressively than peers reliant on third-party suppliers. The result is a deflationary spiral in which every technological advance BYD achieves lowers its cost basis, while competitors, bound by external contracts and standard supply chain timelines, struggle to keep pace. In effect, BYD's new motor and charging platform function as both technological and financial scorched earth tactics. They set a moving target that undercuts rivals' margin structures and forces them into catch-up mode rather than innovation mode. On a broader scale, the introduction of such a high-performance electric motor intensifies the global EV technology arms race, with profound implications for standards bodies, regulatory agencies, and national security planners alike. Governments that have anchored their industrial policy frameworks on the promise of level playing fields may find those assumptions upended. Once a single automaker establishes a hardware benchmark 2 or 3 model cycles ahead of the field, it can compel legislation and certification timelines to align with its own roadmap. In China, where BYD enjoys both domestic market clout and political favor, the likelihood of quick regulatory accommodation, whether in the form of fast-track homologation or preferential charging infrastructure subsidies, is high. Conversely, in markets that impose strict performance or safety testing, rivals may face extended approval processes, further widening BYD's advantage. The competitive ramifications extend into consumer psychology as well. Car buyers who weigh performance figures increasingly treat range and charging speed as cardinal virtues. BYD's portrayal of 5-minute charging for real-world 400 kilometers range reframes the consumer conversation. No longer is fast charging an attractive option, it becomes a baseline expectation. When a major OEM's latest model requires 20 minutes to deliver what BYD promises in only 5, the perception of technological lag crystallizes in showroom negotiations. Dealers, keenly aware of residual value projections, will adjust used car valuations accordingly, creating a compounding erosion of resale value for non-BYD models, and thereby reinforcing the perception that only BYD's technology preserves long-term asset value. This creates a feedback loop. Higher resale values bolster leasing and finance terms for BYD vehicles, which in turn attract more buyers into fleets that renew on shorter cycles. As these cycles accelerate, the fleet management segment, responsible for a significant share of urban EV uptake, leans ever more heavily toward technology leaders. Car-sharing services, ride-hailing fleets, and corporate lease programs all internalize the cost-saving benefits of rapid charging and high-efficiency motors, skewing procurement in a way that further disadvantages late-stage adopters. Ultimately, the decisions of a relatively small number of fleet operators cascade into broader market share shifts, reshaping the competitive landscape around BYD's new technical benchmark. Internationally, the shockwaves are equally pronounced. In Europe, where BYD already surpasses Tesla in market share, the advent of true megawatt charging will accelerate talks with regulators and grid operators to expand ultra-fast corridors along major transit routes. The European Union's fragile consensus on energy and infrastructure spending may, under pressure, redirect investment toward megawatt stations, effectively endorsing BYD's standard. In North America, where tariff barriers have historically slowed BYD's entry, the commercial imperative of competing with performance leaders may prompt trade policy revisions. Concessions on import duties, experimental pilot zones for megawatt chargers, or bilateral tech transfer agreements designed to level the playing field. In each region, the political negotiation follows the technology. By setting a new performance bar, BYD transforms rivals' legislative lobbying from defense in depth to damage control. There are, of course, technical hurdles on the road to truly mass-market megawatt charging. Battery cell chemistry must tolerate ultra-fast currents without accelerated degradation. Cooling systems must manage thermal spikes. Grid operators must provision adequate local capacity without triggering brownouts. Yet BYD's parentage, rooted in battery manufacturing, gives it a head start in resolving these challenges. The company's blade battery design, already field-tested in millions of units, can sustain higher charge rate tolerances, and BYD's systemic testing protocols have, by its account, validated extended life warranties even under extreme charging regimens. For competitors, replicating such integrated testing environments or trusting outsourced validation presents logistical and financial barriers that can slow their response by multiple quarters. The psychological impact of Wang Chuanfu himself as a figure should not be underestimated. Often likened to a nutty professor for his obsessive tinkering and hands-on leadership style, Wang embodies BYD's dual identity as a technology innovator and industrial powerhouse. His personal credibility lends a narrative coherence to the new motor's launch. When Wang steps onto the stage to drive home the implications, the market perceives a convergence of vision and capability. This human element, rare in an industry accustomed to polished corporate spokespeople, galvanizes investor and consumer confidence alike. It suggests that BYD's announcement is not just marketing bravado, but the tip of an iceberg shaped by years of incubation and relentless iteration. BYD's new high RPM, high power density motor and the supporting 1.000V Super E-platform architecture constitutes nothing less than a tectonic shift in the EV landscape. By redefining performance benchmarks, compressing cost structures through vertical integration, and leveraging political capital to secure infrastructure rollouts, BYD positions itself not simply as a competitor among many, but as the firm to which all others must respond. For automakers who believed they merely needed to keep pace on battery chemistry or software suites, the message is clear. The next frontier is holistic system design. Motors, inverters, charging, and integration, and BYD has just raised the bar into the stratosphere. Whether the industry will regroup and mount a coherent counteroffensive, or splinter under the weight of this new standard, remains the defining question of the next chapter in the electric vehicle revolution. Wang Chuanfu's unveiling did more than merely signal a technological leap. It crystallized a strategic vision for the future of mobility, one in which electric propulsion is inseparable from the ecosystems that support it. Consider the hidden battleground of raw materials: rare earth elements, copper, silicon carbide, high-performance polymers, and advanced lubricants. BYD's in-house capabilities in procuring and refining these critical inputs give it an edge even before production begins. By locking in long-term contracts with mining operations and forging partnerships on joint exploration projects, BYD can smooth out price volatility and ensure steady throughput. Competitors, meanwhile, remain vulnerable to spot market gyrations or supply squeezes imposed by geopolitical events, from export restrictions to developing world unrest. Every ton of neodymium or kilogram of copper that BYD secures becomes not just production feedstock, but a strategic stockpile, one that over time tightens the screws on automakers lacking similar upstream integration. Closely intertwined with material security is intellectual property. BYD has, over the years, amassed a portfolio of patents covering motor topologies, magnet formulations, inverter control algorithms, and thermal management systems. What many outside analysts overlook is that these patents are not defensive barriers to litigation, but blueprints for principled design. Through cross-licensing with academic institutions and government labs, BYD has built an R&D network that taps into cutting-edge university research, then funnels breakthroughs directly into its development pipeline. That pipeline, streamlined by a flat organizational structure and direct CEO involvement, often outpaces the glacial timelines of joint ventures among legacy automakers. The result is a self-reinforcing cycle. BYD's IP attracts research partners. Those partners generate innovations. BYD converts them into next-generation hardware. And the cycle renews at ever shorter intervals. This perpetual innovation rhythm has economic repercussions for the broader EV supply chain. Suppliers of bearings, shafts, cooling jackets, and power semiconductors now face terse contract negotiations, with BYD specifying tolerances as tight as +2 microns for rotor bearings and demanding silicon carbide wafers graded for 1in, 106 defect rates. Marginal suppliers find their cost structures untenable unless they invest heavily in ultra-precision tooling, an investment that only pays off if they win large volume orders. And with BYD's own gigafactories scaling at breakneck pace, those orders remain disproportionately with the Chinese giant. In effect, BYD's standards become de facto industry standards, whether suppliers like it or not, forcing consolidation or exit among smaller component makers. From a manufacturing standpoint, BYD's modular cell-to-chassis architecture dovetails with its new motor and power electronics to streamline assembly lines. Instead of juggling disparate sub-assemblies, BYD's plants are organized around complete propulsion modules that integrate motor, inverter, gearbox if used, sensors, and cooling circuits into a single drop-in unit. This approach slashes assembly complexity, reduces labor hours, and minimizes quality control touchpoints. Rivals still building cars by aggregating parts from multiple vendors face higher overhead and slower ramp-up for new models. When the time comes to launch next-generation vehicles, designed around BYD's 1000V platform, they will need costly retooling or face suboptimal performance due to legacy chassis constraints. A ripple effect touches dealerships and service networks. BYD's sleek module architecture simplifies repairs. A malfunctioning propulsion unit can be swapped in minutes, rather than laboriously disassembled on the workshop floor. This not only boosts uptime for vehicle owners, but transforms after-sales economics. Extended warranties and subscription-based maintenance plans, underpinned by predictable service intervals and modular spare parts logistics, become lucrative revenue streams. Competing brands, tied to complex multi-vendor contracts for parts and service, struggle to match both the cost and convenience of BYD's offerings. From the customer's perspective, total cost of ownership increasingly favors vehicles built around integrated systems rather than piecemeal assemblies. On the software side, BYD's control algorithms exploit the high-frequency switching capabilities of its silicon carbide inverters to implement advanced torque vectoring strategies and regenerative braking profiles that adapt in real time to driving conditions. Over-the-air updates can recalibrate these algorithms to improve efficiency or performance as battery chemistry evolves over the vehicle's lifetime. The new high RPM motor, with its expanded operational envelope, unlock software features, such as dynamic shifting between series and parallel hybrid modes in plug-in variants that are impractical on older hardware. For OEMs still reliant on third-party control unit suppliers, customizing such features requires months of development. For BYD, it's a matter of pushing new firmware to the fleet. The ripple extends to the energy ecosystem. If BYD's megawatt-level charging becomes commonplace, grid operators will need to rethink demand response strategies and time-of-use pricing. Commercial buildings and residential complexes may install on-site energy storage or microgrid controllers to manage peak loads, giving rise to a parallel industry in distributed energy management solutions. BYD, with its expertise in battery storage systems for grid applications, stands poised to fill that niche, bundling home chargers with second-life battery packs in cost-effective packages. Thus, BYD's propulsion breakthrough catalyzes an entire value chain pivot toward electrification at every scale, from personal mobility to building electrics to utility-scale storage. Geostrategically, BYD's ascendancy alters the balance of power in automotive diplomacy. Countries keen to develop domestic EV industries must reckon with a single foreign competitor whose cost efficiencies and scale make local champions less viable. Nations that seek to insulate their markets through tariffs risk erecting barriers that deter foreign investment, not only of cars, but of charging infrastructure and battery factories. Conversely, economies that seek to attract Chinese capital may need to offer incentives for joint manufacturing ventures or technology transfer agreements, effectively conceding market share to retain industrial activity. BYD's technological lead thus becomes a lever in trade negotiations, infrastructure partnerships, and even soft power initiatives, as governments weigh the benefits of aligning with or resisting China's EV juggernaut. Environmental and social considerations further complexify the picture. BYD's blade battery chemistry boasts improved thermal stability and reduced cobalt content, addressing some ethical and safety concerns in the supply chain. If the high RPM motor platform can be paired with these batteries to achieve longer cycle life, it diminishes the environmental footprint per kilometer driven. However, the mining intensity of rare earth and critical metal extraction remains a pain point. A surge in demand for high-performance magnets could exacerbate ecological degradation unless mitigated by recycling initiatives or alternative chemistries. BYD has signaled investments in magnet recycling technologies, but scaling those processes will be vital to ensure that the environmental calculus of ultra-high-performance EVs remains sustainable. Education and workforce development are rarely discussed, but are crucial downstream effects. As BYD's modules come to define modern EV architectures, technical curricula at vocational schools and engineering programs will need revision. Mechanic certification will pivot toward high-voltage safety protocols, power electronics diagnostics, and software-centric troubleshooting. BYD's influence on curriculum design, potentially through partnerships with educational institutions, could standardize training around its own systems, making its technology even harder to displace in service markets. In consumer culture, automotive journalism and enthusiast communities will recalibrate their frameworks for evaluating EV performance. Track day reports will highlight the torque curve of BYD's new motor, while road trip narratives will emphasize 5-minute charging stops. Enthusiast forums, which once debated kilowatt-hour consumption per 100 kilometers, will pivot to analyzing battery cycle health under ultra-fast charge-discharge cycle. This reframing of performance from purely speed and handling to include charging kinetics and energy density represents a paradigm shift in how cars are experienced and reviewed. Consider the longer arc, the coming convergence of electric propulsion with autonomous driving and smart city infrastructure. BYD's modular propulsion units, with standardized electronic interfaces and high-voltage networks, lend themselves to centralized fleet management systems. Autonomous shuttle pilots in urban districts could deploy BYD-powered vehicles with predictable charging and maintenance profiles, simplifying logistics for operators. Smart city planners, designing curbside charging zones and dedicated EV lanes, will factor in the rapid charge footprint required by these high-throughput modules. In effect, BYD's motor becomes not just a component inside a car, but a node in a distributed mobility network, a harbinger of a world where vehicles communicate with grids, roads, and each other in real time. Wang Chuanfu's stagecraft in unveiling the motor may have stolen headlines, but the deeper narrative is one of system-level orchestration. Few realize that what appears as an EV motor is, at its core, a nexus of supply chain strategy, IP management, manufacturing innovation, software integration, and geopolitical influence. The full ramifications will unfold over years as competitors react, regulations adapt, and markets recalibrate. What is certain, however, is that the boundaries of what constitutes an electric vehicle and the ecosystems that sustain it have just been redrawn. And in that redrawing, BYD has positioned itself not merely as a participant, but as the cartographer of the next age of mobility. The rapid emergence of BYD's advanced motor topology also prompts a re-evaluation of finance and insurance practices in the automotive sector. Lenders and insurers have traditionally relied on historical depreciation curves and repair cost models derived from internal combustion vehicles. However, as electric drivetrains evolve with modular architectures and ultra-fast charging capabilities, these legacy models lose predictive power. Insurers must recalibrate risk assessments to account for new failure modes, such as semiconductor breakdowns or software glitches in torque management systems, while financiers will need to update residual value forecasts to reflect the premium that BYD's technology commands. Specialized insurance riders tied to charging behavior, battery health, and firmware update history may become commonplace, creating a bespoke ecosystem of financial products that mirror the underlying technological sophistication. In parallel, automotive aftermarket businesses ranging from customization shops to accessory suppliers face a landscape in flux. Enthusiasts who once invested in turbochargers and performance exhausts now seek upgrades for charging cables, thermal control modules, and even magnet upgrades for higher torque output. The performance tuning industry will pivot towards software flash tools that tweak inverter switching frequencies or recalibrate regenerative braking curves. Fabricators capable of producing high-precision motor housings or custom cooling ducts may find new markets, but only if they master materials such as high-strength aluminum alloys or carbon fiber composites that can withstand the stresses of high RPM operation. The aftermarket's DNA, rooted in mechanical know-how and hands-on modification, must adapt to an era where performance gains are as much about electronics and software as they are about mechanical hardware. BYD's latest developments also spur fresh conversations about intellectual property strategy on a global scale. As the company's patents on high-power density motors and 1000-volt systems gain prominence, we can anticipate defensive filings by competitors aimed at either blocking BYD's freedom to operate or creating cross-licensing leverage. Legacy automakers with deep pockets may pursue broad patent portfolios in adjacent domains, such as battery thermal management or power architecture designs, to create patent thickets that complicate BYD's expansion outside China. At the same time, startups will seek to carve out niches in complementary technologies, such as next-generation silicon carbide chip fabrication or alternative magnet compositions, hoping to become indispensable suppliers to both BYD and its rivals. In academia, the unveiling accelerates interest in specialized research programs. Universities will establish lab courses and graduate theses focused on megawatt-class charging dynamics, advanced cooling strategies for high-speed rotors, and the material science of low-cobalt or cobalt-free blade batteries. Research funding agencies, recognizing the strategic importance of these areas, may channel grants toward public-private partnerships that tap BYD's facilities for pilot testing. This cross-pollination could yield unforeseen breakthroughs, perhaps in superconducting motor windings or solid-state battery integration, but it also risks funneling academic talent toward a single corporate ecosystem, potentially narrowing the diversity of research directions. Meanwhile, labor markets and manufacturing hubs will feel new pressures. Assembly line workers accustomed to multi-step processes may require retraining to manage modular propulsion units, which demand precision alignment tools and electrostatic safe handling protocols. Robotics specialists will be in high demand to program automated cells that install motors and inverters with micron-level accuracy. Training centers and vocational programs will need to collaborate with BYD and similar firms to develop certification pathways, ensuring a pipeline of skilled operators who can maintain the tight tolerances these new technologies demand. Consumer sentiment studies will soon capture the shift in buyer expectations. Market research firms already survey prospective EV purchasers on metrics like time to charge and motor replacement costs per kilometer. BYD's promise of rapid charging and simplified propulsion maintenance will alter these survey benchmarks, leading to new indices that track consumer confidence in emerging EV systems. This data, in turn, will guide marketing narratives across the industry, pushing every automaker to underscore not only battery range and motor power, but also ecosystem reliability and upgrade pathways throughout a vehicle's life cycle. Environmental organizations and policy think tanks will also recalibrate their evaluations of electric mobility's total impact. While high-performance motors reduce the energy consumption per kilometer, the intensified extraction of rare earth elements demands heightened scrutiny. NGOs may advocate for transparency in supply chain sourcing or for robust recycling mandates that prevent magnet-laden scrap from entering landfills. BYD's investments in reclaimed magnet processing could serve as a model, but environmental watchdogs will press for industry-wide standards, insisting that high RPM efficiency does not come at the expense of ecological integrity. On the geopolitical front, the motor's unveiling intersects with broader questions of technological sovereignty. Nations dependent on automakers headquartered outside China may worry about over-reliance on BYD's platform. To hedge against this, some governments may accelerate subsidies or tax breaks for domestic motor research initiatives, sometimes even duplicating efforts already underway at BYD. This reaction could result in a bifurcated global standard, one centered on the 1,000-volt silicon carbide-driven architecture championed by BYD, and another based on alternative approaches backed by Western consortia. The divergence of standards could complicate international trade in both vehicles and infrastructure equipment, potentially leading to region-specific charging protocols and motor designs. At the same time, BYD's breakthrough will catalyze alliances among automakers who feel threatened. Joint ventures aimed at developing rival high-speed motors could emerge, combining the strengths of European metallurgy experts, American semiconductor firms, and Japanese machine tool manufacturers. Such alliances will aim to pool R&D resources, share risk, and create critical mass to negotiate with suppliers. Yet coordinating these global coalitions presents its own challenges, from aligning IP policies to integrating disparate corporate cultures. Success will hinge on mutual trust and clear governance structures, qualities that large incumbent alliances have sometimes struggled to achieve. The media landscape itself is evolving in response to this shift. Tech journalists and mainstream outlets are devoting more coverage to the intricacies of inverter topologies, cell-to-chassis design, and magnet economics. Specialized podcasts feature interviews with motor designers and charging infrastructure planners, while YouTube channels demonstrate tear-down videos of BYD's modules, probing the microarchitecture of windings and the layout of cooling channels. This granular focus reflects a maturing audience that demands more than horsepower figures. It wants to understand the technological DNA behind performance claims. As a result, content creators with expertise in electrical engineering and materials science will gain visibility, influencing public understanding and expectations. The cultural dimension of mobility is refracted through the lens of lifestyle and identity. Early adopters of ultra-fast charging EVs may form online communities that share road trip itineraries based on the availability of megawatt charging stations. Influencers will showcase the freedom to traverse continents with minimal charging downtime, framing distance and speed not just as technical feats, but as enablers of new travel narratives. These stories will shape the aspirational appeal of electric mobility, reinforcing the association between advanced propulsion technology and a modern, connected lifestyle. In weaving together these threads, financial re-engineering, aftermarket transformation, intellectual property strategy, academic realignment, workforce development, consumer psychology, environmental stewardship, geopolitical maneuvering, alliance formation, media evolution, and cultural reinvention, it becomes clear that BYD's new motor is more than a component. It is a catalyst for systemic change. The ripples will be felt in boardrooms and garages, classrooms and parliament halls, charging station networks and social media feeds. For better or worse, the contours of the automotive world have shifted, and every stakeholder must plot a course through this newly redrawn terrain. The question is no longer whether electric vehicles will prevail, but which actors will emerge as the architects of the next mobility paradigm. If you liked this video, please give it a like and subscribe to our channel. Also, leave your comments below and tell us, what are your thoughts on BYD's new engine? Will it really destroy the EV industry? We want to hear from you. Thank you for watching, and see you next time.